Hey everybody, so I just wanted to take a minute and do one example from each section. We should have covered everything in your notes yesterday, but just in case you weren't here, or I know sometimes it's just nice to see an example. So I'm just going to go through real quick, do a couple examples, and then let you get to work. So on this first one here, all you got to do is just fill out the table here. So really, this is just kind of testing to see, do you know your unit circle values, right? So I'm going to take the angles, plug them into my sine or cosine, and then at the end, I'll multiply by -2. So cosine of -pi/2. So cosine of -pi/2 is 0. -2 times 0 is 0. Okay. Plug in -pi/4. Cosine of -pi/4 is positive radical 2/2. And I'm going to multiply that by -2. Those 2's cancel out, so this be negative radical 2. Okay, so you get the idea here. So I'll just go ahead and pause the recording and fill out this table. You're just going to plug in the value, evaluate the cosine, and then multiply your answer by -2. Okay, so there's what your table should look like. Hopefully you came up with these same values. Just be careful with the signs. Make sure positive or negative. Remember, you're multiplying it by a negative number. Okay, so hopefully nothing too crazy there. Just kind of getting used to plugging in values and evaluating those. All right, the next one says find at least 4 x-intercepts for each function. So we talked about yesterday, to find the x-intercepts of any function, you're going to set your y value equal to 0. So I set y equals 0, and then I just got to solve for x. So add 1 to both sides. And I'm going to take the inverse cosine of 1. So I'm looking for angles that have an x value of 1. So it happens at 0 and 2 pi. All right, so 0 and 2 pi, but it says I need at least 4 x-intercepts. So how am I going to find more of these? So now we kind of got to go back to what we were talking about a while ago with our coterminal angles. So we're looking at this point right here on the unit circle has a cosine value of 1. So 0, 2 pi, I could go all the way around again. That'd be 4 pi. All the way around again would be 6 pi. So we could do 4 pi and 6 pi. Those could be 2 good x-intercepts. Or if you want to throw some negatives in there, remember we could go clockwise all the way around. So you could do -2 pi. So those would be x-intercepts there. Okay, so the gist for this section is you're going to set the equations equal to 0, because that's how we're going to find our x-intercepts. And then you're going to solve the equation, and then you might have to do some coterminal angles to figure out how to find 4 x-intercepts, because most of the time when we do our unit circle stuff, you're probably going to have 2 that just kind of naturally pop up from doing the inverse sine or cosine. Okay. All right, on the next page, it says find the y-intercept. So any y-intercept ever that we're going to find by plugging in 0 for x. So we're going to find f of 0. So cosine of 0 minus 1. Cosine of 0 is 1. So I have 1 minus 1, which equals 0. So my y-intercept is 0. Okay, so nothing too crazy here. You're just going to plug in 0 for x and then evaluate. All right, and then last thing at the bottom. So, last thing on this page, I guess. So you're going to fill out your tables just like we did up above. You can even you might be able to use all the same strategies that we used up here, right? So you're going to plug in these values, and then I just want you to plot these points. So let's go ahead and plot a couple of these together. So if I plug in -pi/2, cosine of -pi/2 is 0, 2 times 0 is 0, 0 minus 1 is -1. And then I'm going to come over here. This is -pi/2, comma, -1, and just plot a point. Okay. Plug in -pi/4. Cosine of -pi/4 is radical 2/2. So 2 times radical 2/2 is just radical 2. And then I'm going to do -1. So I might just leave a radical 2 minus 1. If you want to type that in a calculator, you can. Radical 2 is just a little bit more than 1. So when I plot this, it's going to be just a little bit bigger than 0. So something like that. Okay, plug in 0. Cosine of 0 is 1. 2 times 1 is 2. 2 minus 1 is 1. So 0, 1 is a point. Plug in pi over 4. So you get the idea here, right? We're going to plug in these values. We're going to come up with the value that we're going to plot. And then we're going to just plot those points on the graph. And then when we're all done, we should have a decent graph. It doesn't have to be anything perfect, but something decent that we can graph. That'll have a nice little sine or cosine curve. Okay. All right. And then the last thing I want you to do on this page, you're just going to find the period and the amplitude. So remember the amplitude is just the leading coefficient out in front here. So these are just amplitude 1, amplitude 4, pretty simple stuff there. And then period is equal to 2 pi over b, where your b value is this value next to your x. So you're just going to do 2 pi divided by 4, which is just pi over 2. And this one would be 2 pi over 5. That doesn't reduce. Over here, just be 2 pi. So you're just finding the period and the amplitude there. All right. And then on these graphs, you're going to do your best to kind of formulate an equation. So these might be a little tougher. We probably didn't do many of these in class. I'm recording this before we have our lesson, but remember to find the period. It's just how long until your graph repeats. So if I look at this little section right here, so this is 2 pi. So they're trying to show you that this point right here, this is bad drawing. This is supposed to be pi. So your period is pi. So how long does it take for the graph to repeat? Well, if I start at this point, I go up, down, back up. It took me pi units to repeat. So there's my period. My amplitude, look at your max and your mins. So your amplitude is 3. Okay, so now I got to try to figure out what my equation is. So this is a sine curve because it goes through the origin. So y equals 3 is the amplitude times sine. And then I need my b value, right? So remember, your period is equal to 2 pi over b. In this case, your period is pi. So it's going to be pi equals 2 pi over b. Multiply both sides by b. So b pi equals 2 pi, which means that b is equal to 2. So the equation would be y equals 3 sine of 2x. Okay. So depending on what we got done in class, that might be a bit of a stretch. You know, my guess is maybe we didn't get to do very many examples of those. So just try your best. Okay. What I care most about is, can you get the period in the amplitude? Can you answer the question, how long until the graph repeats? So if you look at this next one, starts at the top, down, back up. Okay. So it took 2 pi for my graph to start to repeat. So my period's 2 pi, amplitude's 4. Okay. To find the equation, 2 pi over b is equal to 2 pi. So 2 pi equals 2 pi times b. Divide both sides by 2 pi. So b equals 1. Okay. And then we can try to put that together with an equation. If you get stuck, that's okay. Okay. You do not have to do this last page today. Okay. So hopefully you watched the video and you saw that you do not have to do the last page. I'm not expecting you to graph these yet. We'll work on that next time I see you. So don't worry about doing the last page. You don't have to do any of these. All right. So just the first 3 pages in the packet. If you struggle at all, just try your best. Hopefully the video helped you at least get started, and we'll talk to you guys soon.